I'm in the utility room, and this behind me is what's called an air handler. Air handlers, they're similar to a furnace, they just work a little bit differently. I'm in the utility room, and this behind me is what's called an air handler. Air handlers, they're similar to a furnace, they just work a little bit differently. So an air handler, what it does for heat is instead of burning natural gas, putting it into a heat exchanger, and then sending the house air over the heat exchanger, what this does is it has a radiator. And that radiator will take, just behind me here, I'll show you the water heater in a second. There's an on-demand water heater, so that will heat the water, send it through these two water lines that you can see right here. Okay, these two right here. You have a hot and a return line. So hot is the inlet, you're bringing water into that radiator. The fan down in the bottom is blowing house air over that radiator, which is heating the air up, and then that sends that warm air up to the house. So this piece that you see right here in front of me, let's see if I can get you right in there. This camera's not going to get in there very good. Okay. Let me get my flashlight here. Okay. So this right here is the radiator. So what you're looking at, you have your water lines down in the bottom. Here's the pump. So this little black piece right here is the pump. That is what is circulating water from this radiator over to the water heater over there. So as the water is circulating through the radiator is warm. The fan down here in the bottom will force the air through that radiator and then send that air up into the house. Okay. So this is an on-demand water heater. When you take a look at this, this is doing two jobs in a house. One, it heats the water up so that when you turn on a faucet and you want hot water for a shower or doing the dishes, washing your hands, this supplies the hot water that heats the water up to send to the faucets. Its second job is to heat the water that goes to the air handler, or most people would think of it as a furnace. That air handler has the radiator. The hot water that is going through that radiator comes from here as well. So this serves two purposes. It does two jobs. It gives hot water to the faucets for your potable water. It sends hot water to a radiator for your forced air heating system. This is made by a company called Rinnai. It was installed the 16th of the 10th month on the 14th year. Okay, so this is 6 years old. In terms of whether or not it's a rental or its own, I would say with this house, because of the age, this is most likely a rental. It's definitely in good shape. Look on the side here. Its heat output is 152,000 BTUs. A regular water heater, like a tank that you would have in your house, they're usually about 40,000 BTUs. With this one, because it's heating the water instantly, it's on demand, it has a much bigger burner. Secondly, because it's doing two tasks, it's heating the house and it's heating the potable water, it has to be capable of doing two jobs at the same time. So if I'm heating the house, I don't want to suck all of that hot water out, so when you go to have a shower you don't have any hot water. So that's why these are so powerful, is it needs to do two different jobs. It needs to heat the house and it has to heat the water for the potable water system as well. This here is what's called a heat recovery ventilator. What heat recovery ventilators do is they bring fresh air into a building. Newer houses are sealed up so tight that there's very little draft in the building. So fresh air coming into the building really only happens when you open windows and doors. There's no drafty walls, no drafty windows. So in terms of energy efficiency, new buildings are very energy efficient, but their air quality is poor. You know, in the winter when you're just not opening your windows, or in the summer when it's hot and you have your air conditioning on, you're just not opening your windows. What this does is this sends some of the air in the house outside, and it replaces it with outside air. And in the middle of it, there's this little diamond-shaped box that is a heat exchanger. I'm going to show you that. And just lift this top cover panel off. Oh yeah, there you go. Okay. So this little, or this diamond piece that you see in the middle, what's happening here is you have air from inside the house, goes down through here, and then gets exhausted outside. Then you have outside air coming in through here, comes down into here, and then that gets drawn into the heating system. So heat recovery, what it's trying to do is as you're sending that stale air from inside the house, as you're sending it outside, it goes this way through here. And what that does is it tries to preheat some of the air coming in from outside so that when it goes into the furnace, at least you've warmed it up a little bit. In terms of how efficient these are, when it's minus 30 outside, you are not going to take 22 degrees Celsius air and reheat or preheat minus 30 air up to 22. It just doesn't happen. In terms of how efficient these are, it's better than opening a window, but they're a great idea. For newer houses, they definitely help improve air quality. In terms of how frequently you should use these, there's really 3 settings with it. You can have it turned off, you can have it turned on intermittent, which means if the furnace is running, this is running, or you can just turn it on and leave it on, and you can set the speed that the fan is turning. Think of this as a really fancy way of opening a window. If it's minus 30 outside and you just leave this running all the time, there's going to be a lot of cold air being brought into your house, and your heating bill will be big because of that. So, you know, every time you turn this on, think about how long you would want to leave a window open. With these, intermittent is a good setting. If you're having a party and there's people over at your house and you want to get rid of the humidity that's in the house and bring fresh air in, setting it up, putting it on and leaving it at either low or medium is a good idea. Kind of your in-between seasons, the time that you don't want to run this, the time that it should be turned off, is in the summer. Your humidity levels outside in the summer are so high that what ends up happening is you suck a lot of humidity into the building, and then you start getting condensation issues. So your basement, if you notice in your basement that on the insulation there's a lot of condensation, you'll see water streaking down the back of the vapor barrier on the insulation. A lot of the times it's because you've got this on and you're sucking in that humid air from outside. It's getting into the basement where it's cold, it's condensing on that cold concrete and then dripping down onto to the bottom of the vapor barrier. So in terms of running this, don't run it in the summer because you don't want to pull all that humidity into the building. When it's minus 30 outside, you probably don't want to leave this running 24/7 on high speed because your heating bill is going to be really big. There are 2 filters on these. Okay, there's this one here. Okay, this one does the inside air. Okay, that is very dirty. That definitely needs to be washed. You can just take that to the laundry tub and wash that out. Then there's the outside air coming into the building, is this one here. Okay, and again, that one's pretty dirty. That's going to be just dust and grass clippings, things like that. So that will need to go to the laundry tub and get cleaned as well. So in terms of HRVs, I like them on new houses. I think they work really well. Just keep in mind when you want to run them. Also keep in mind that there is maintenance that goes along with cleaning the filters.